Let's do this. Remember, okay, first and foremost, when you first learned how to find inverse functions, and when you went through it again last year, what you first talked about was not all functions have an inverse function. And you learned that in order for a function to have an inverse function, it has to pass the horizontal line test. You remember that? So, for example, when you have a function that looks like this, it does pass the horizontal line test, meaning its inverse is a function. It has an inverse function. But if you've got a parabola, it does not pass the horizontal line test, meaning it does not have an inverse function. So now, taking that with us to trig, you can see that when I graph a sine function, it definitely does not pass the horizontal line test. So does that mean we're just doomed to never talk about inverse functions? Yeah. Not at all. Just like in the parabola, it's not so easy. Just like in the parabola, one way around it was to just take half of the parabola, right? Because now that would have an inverse function. In the case of the sine function, we can do the same. So look at this. That's the full-fledged sine function. However, if I were to only take one portion of it, right, just that function in the green, now that does pass the horizontal line test, and I can find the inverse function of that one. Okay? So, what I've done here is I'm just taking that green part and I'm going to throw away the rest, meaning I have restricted the domain of the sine function from all reals to just that. And let's see how much we did restrict it. This point here, that's negative pi over 2, and this is positive pi over 2, right? So the only part that I'm taking is from negative to positive pi over 2. Okay? Now, let's see which angles we took with us when we did this. So we have 0, and then moving to the right, I have pi over 6, pi over 4, pi over 3, right? And then you've got pi over 2. And then on the opposite side, I've got negative pi over 6, negative pi over 4, negative pi over 3. Okay? Let's think about it a different way. Suppose I was on the unit circle. Okay? This is 0. This is pi over 2. And now if I take the stuff from the 0, from the y-axis over to the right, what do I have? I have that region from 0 to pi over 2. So that's that quadrant, right? And I've got pi over 3, pi over 4, pi over 6, correct? And then what other region do I have? This region. Where does that correspond to the unit circle? That's the region from 0 to negative pi over 2, which here it's the bottom, correct? 0 to negative pi over 4. So negative pi over 6. So now my restricted domain, that's a 3. And then negative pi over 2. So now my restricted domain only corresponds to those two quadrants, okay? Now, okay, so let's talk about something else. When I restricted the domain from negative pi over 2 to pi over 2, the range, right, it's still from negative 1 to 1, correct? But now, so let's take a look. So for my f of x, the domain is from negative pi over 2 to pi over 2, and the range is from negative 1 to 1. But when I take a function and I go to the inverse function, right? When you learned how to find inverse functions of like a parabola, right? What was the first thing you did? Switch x and y, correct? And when you switch x and y, you also switch with it all of the domain and all of the range, right? So if the domain for f of x was negative to positive pi over 2, that now becomes the range for the inverse. Okay? And the range of f now becomes the domain of the inverse. Okay? All right? So now, okay, so before my y values for sine of x were from -1 to 1, correct? Now for inverse functions, my y values are going to be from negative pi over 2 to pi over 2, and the x values are going to be from -1 to 1. All this is going to become a lot less, mysterious in a minute. So with this, once we restrict the domain, we can now find the inverse sine function. The way we write that is inverse sine like this, sine to the inverse 1, -1, or arc sine of x. Those two mean the same, sine minus 1 or arc sine. Okay, so we're not going to graph the inverse sine function here, but when you do graph the inverse sine function, so you see the red here, I'll highlight it. The inverse of that, actually when you graph it, looks like this bottom one here. Okay, so when you graph the inverse sine, do you see how it goes from negative pi over 2 to pi over 2 on the y-axis and -1 to 1 on the x-axis? Okay, what does it all mean? Okay, what does it all mean? Until now, I would give you this sine of pi over 3, and you would say, that's root 3 over 2. Yes? Now we're going to switch it up. Now I'm going to ask you inverse sine of root 3 over 2, which means, right, if I was walking down the street and I saw that on a billboard, just that on a billboard, I would say, oh, someone's looking for the angle for which the sine is root 3 over 2, right? And you would all tell me, oh my God, Miss Malikan, that's how much? Pi over 3. Okay?
I can't wait to see a billboard.
I know, right?
Yeah.
So
One day we're gonna see him.
one day, and you're gonna think, Matt.
I think you should make a billboard.
I know. I think we should pitch in, just buy a billboard.
If I see this, I'll email you all. I'll let you know.
So the number that goes in here represents a number in the domain. Okay, that represents a number in that's a member from the domain, and the domain for now is -1 to 1. So in that parentheses, that's now the new domain for the f of f inverse. You can only have numbers that go from -1 to 1. So for example, I can never have inverse sine of 4 because that's not from -1 to 1. These values here, the answer to the inverse sine question, these are members from the range, and they go from negative pi over 2 to pi over 2.
Is it always going to be those two?
Domain and range, yes. Now, in other words, the answer to inverse sine of x, okay, is always going to be the angle. And that has a range of negative pi over 2 to pi over 2. Okay, so moving forward, is it an absolutely emergent question? Okay. Okay, then if not, later. Okay, so because I'm on a roll here, Gabe. I'm on a roll. Okay, so, okay, now find the exact value of each expression. Okay, the answers to these are the angles. Now remember, our domain is restricted from -1 to 1, our range from negative pi over 2 to pi over 2. What we did, I'm just going to draw that here again. This is going to be your friend. You just have to know it, right? The only thing that is The only angles that are included in this realm of inverse sine, okay, are the ones on the right. So for example, from negative pi over 2 to 0 to pi over 2. And again, these were pi over 3, pi over 4, pi over 6, and so on. So in essence, I can erase everything on the opposite side, and that's all that remains in this realm. How many total angles are these?
10.
Okay, it's somewhere in the middle there. 9. We finally hit it. 9, 8, 7, 9. There are 9 angles, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Meaning, when you have an inverse sine problem, the only answers you can possibly have are one of those 9 numbers. Okay, always. So for example, where is 7 pi over 4? Is it part of the 9? No. So it can never be an answer. All right? Can you just no, thank you. Okay, and that thank you. Yep. That's not cool. Thank you. Okay.
Not cool.
Okay. Let's move on. All right. So here we have inverse sine of root 2 over 2. What's the angle for which the sine is root 2 over 2? Pi over 4. Fabulous. Inverse sine of negative 2 pi. Why not? Okay, okay, this is a trick question. Because what did we say? We said the number in here should always be between negative 1 and 1. But negative 2 pi has a value of how much? Negative 2 pi itself is negative 6.28. Right? It's a trick question. That is a value of negative 6.28. It's not in the domain. Must be between negative 1 and 1. Okay, so this one you just say not possible.
You say no solution?
Either, Okay, you know what? Let me give you some more examples here. Part C. Why don't we do inverse sine of negative a half? Where is sine equal to negative 1/2? For what angle?
2 pi over 3.
Okay, is 2 pi over 3 in that domain?
It's no, I think it's 5 negative 5.
Pi over 3.
Okay, so sine of pi over 3 is root 3 over 2. So that's not the one. For what angle is sine 1/2? Pi over 6? Negative pi over 6. Okay? Yes. So, sine of pi over 6 is a half. So when you want sine to be negative a half, it's got to be the equivalent of, or the corresponding angle to pi over 6 in the negative quadrant. So that's negative pi over 6. Okay, now.
So equals negative pi over 6.
Equals negative pi over 6. So now let's identify one other thing. The top quadrant, right? Is sine positive or negative in the top quadrant? Positive. What about in the bottom quadrant? Negative. So when you want an angle for which sine is negative, you're going to go in one of the bottom angles. When you want sine to be positive, you're going to go in one of the top angles, right? So what's sine of 2 pi over 3? 2 pi over 3 is here.
Not possible.
So sine of 2 pi over, sine of 7 pi over 6. Sine of 7 pi over 6 is negative a half, right? Look, remember from like section 3, from what you had on the quiz. Sine of 7 pi over 6, it is negative a half, okay? But why can't that be an answer here? Because it's not in the domain. Because where is 7 pi over 6? It's right here. Look at how far away it is from the restricted domain. Here. 7 pi over 6 is here, right after the pi. You see how it's not even close to there? Okay, Z and then G.
So
Jack,
because
sorry.
the unit circle, we only have like the first and fourth quadrant. If you have arc cosine.
Okay, cosine we haven't gotten to yet.
Okay.
Okay? Yeah.
Wait, so the only options for sine inverse would be -1 or +1, and then root 2/2, root 3/2, and 1/2 positive or negative, right?
And 0.
And 0.
Yeah, so it's the special angle values, right? It's whatever you have on the unit circle. So 1/2 root 3/2, root 2/2, and so on. Okay, so, yeah. Okay, so now let's move on to the cosine function. Same way, you have to restrict the function for the cosine, right? So for the cosine, I take this, right? That's how I restrict the domain, right? So you see how for the cosine, it can't be from -pi/2 to pi/2 because that wouldn't pass the horizontal line test either, right? So for cosine, my restricted domain is from 0 to pi. Okay, so now when I draw the unit circle, right, I'm gonna go from 0 to pi. So those two quadrants. So which angles are we talking about? Pi/3, pi/6. And then pi/3 here, pi/2, and then what's next? 2 pi/3 and 5 pi/6. How many total angles? 9 again, and again you've got one quadrant where it's positive, one quadrant where it's negative, right? You're going to have that every single time. Okay, so now, inverse cosine of 1. What do you guys think? For which angle is cosine 1? How much? 0. Can we say 2 pi? No, right? 2 pi, yes, physically on the unit circle, it's here. But where is 2 pi on the restricted domain? Like in another country practically, right? So we can't use 2 pi. Yeah.
So if you give us a problem like this, we're not going to see both the graph. We're not going to see the graph.
No, it'll just be inverse cosine of 1. Okay, arc cosine, which is the same thing as inverse cosine of -√3/2. You guys sure? Yeah? 5 pi/6, 5 pi/6. Okay, so if you go to 5 pi/6 here, right, the cosine is the √3/2, right? Okay, inverse cosine of -2? Huh?
-3/2.
You're sure?
Isn't that like the arc cosine of -3 pi over 2? Like the cosine of -3 pi over 2 is also 5 pi over 6. So what's the difference? Like what's the difference for that one? Because the cosine of like -3 pi over 2 is also 5 pi over 6. So I don't understand how they flip that.
The cosine of 3 pi over 2?
Or no, of -3 pi over 2.
So -3 pi over 2 is here though.
Right.
But the cosine there would be 0.
And the cosine there would be 0.
You mean √3/2 or 3?
Yeah, root 3.
Okay, so say the question again. Okay.
So,
Hey, listen.
But the cosine of root 3/2, isn't that also
The inverse cosine of positive √3/2, you mean? Is that what you mean?
well, yeah, no, just normal cosine of negative, like negative square root 3 and then over 2, or just normal cosine.
Okay, so if you had a normal cosine,
Also quite
right, but if you had normal cosine, it would be like this: cosine of 5 pi/6, and then your answer would be √3/2. Okay, inverse cosine of -2. What is this between -1 and 1? No, so it's no solution or not possible.
Can you put like the 0 on the line to it?
Sure. Okay. Next. Yep.
You say the domain range
For which one?
for just the cosine.
For the cosine, the domain is from 0 to pi. The restricted domain is from 0 to pi. And then the range is always -1 to 1. Okay, now let's go for the tangent. So tangent, it kind of, does its own, right? Because look, you've got one arm of the tangent like this, and that's enough. Like that's all we can take, and it passes the horizontal line test. The difference though is, okay, so yes, we're gonna go from negative pi over 2 to pi over 2, again, like the sign, similar to the sign, but it's different in that the tangent is undefined from at negative pi over 2 and pi over 2. So when I take the unit circle, right, from negative pi over 2 to pi over 2, I've got 0, pi over 6, negative pi over 6, right, the pi over 4s, negative pi over 3, but then pi over 2 and negative pi over 2 are where the tangent is undefined. So those get eliminated from my domain, meaning now I even have fewer angles, just 7. So technically, I mean, theoretically, if you have an inverse tangent problem, you could just throw one of the 7 angles over there and you've got 1/7 chance to get it right. Okay? So, inverse tangent of 1, raise your hand, somebody. Inverse tangent of 1. Okay, thank you for raising your hand. But next time you got to raise your hand. Pi over 4. Okay, now somebody raise your hand. Arctan of root 3 over 3. Arctan of root 3 over 3. Pi over 6. So you have to ask yourself, for what angle is the tangent root 3 over 3? Okay, again, let me remind you this again. I said it once, but I'll say it again. For tangent of the pi over 3 and pi over 6, 30 and 60, you have 2 possibilities. Root 3, 1 over root 3, which is root 3 over 3. Okay? This is the smaller one. And this is the larger number. And this is the smaller number. Okay? This is the tangent for the smaller angle, because that ratio is small. This is the tangent for the larger angle, because that ratio is bigger. Okay, yeah.
I don't know if it's negative or positive.
Oh, so in the first quadrant, in the top quadrant, is tangent positive or negative? Positive. And then in the bottom quadrant,
Oh, I was thinking that.
negative. Okay, so, all right. We're good with this? Yeah. Okay. So here's one representation, like it's basically the summary of everything we've done. Okay? So these are basically different representations of the same thing. This is from another book that I like to throw in here because it's got the domain and the interval, and then it also says like the quadrants, right? So sine has 1 and 4, tangent has 1 and 4, cosine has 1 and 2. Okay. Here we go. Let's move on. Sine of arcsine of a half. So we start from the inside, right? What's arcsine of a half? Pi over 6. Okay. And then what's sine of pi over 6? 1/2. So basically when you have sine and arcsine, they do kind of cancel each other out. It's like doing x divided by 3 times 3. But you have to make sure that the argument here, like the stuff inside, is within the domain. Okay? Okay. Okay, here. All right. Start from the inside. What's inverse tangent of 1? Somebody raise your hand. Inverse tangent of 1. Pi over 4. All right. So now, inverse sine of 1. Somebody raise your hand. Inverse sine of 1. So we're looking for the angle for which sine is equal to 1. Pi over 2. Sine is the y value, so up here.
Yeah.
Okay. So now we're going to do sine of pi over 4 minus pi over 2, which is sine of negative pi over 4, which is negative 1 over root 2. Okay? So it's all like coming back together, yes? Okay, now take a look at this next one. The next one says, I've got, okay, so find the exact value of sine of inverse cosine of 4/5. Okay, let's start from the inside here. That inside, it's saying inverse cosine of 4/5, which means, okay, the story behind this is, there is this mystery angle, the cosine of which is 4/5. Okay? Let's draw a representation of that. The cosine is 4/5. Yeah? So that's the angle we're talking about. You see that? That's that angle theta we're talking about. And then we know that this side is equal to 3, that missing side. Yeah? So now, if I go back outside, right, what's the sine of that mystery angle? 3/5. Okay? So, I have a mystery angle. The cosine is 4/5. Find the sine. There it is. Now, are you always gonna, have like these perfect, cute little numbers? No, you're gonna have roots and so on and so forth. Okay? All right. Yeah.
Are these gonna be posted?
These meaning.
The notes?
So I do post the notes after we finish a chapter. So after we finish this, I'll post it.
Would I be able to actually?
It'll be on my jag.
Oh,
Okay. So next one. Okay. We want cosine of arc sine of x, right? Okay, now this is a little bit different. Let's still draw this inside. There is a mystery angle, the sine of which is x, meaning it's x over 1 like this, yes? Okay, can I find the missing side on the bottom? Let's call that a. It's going to be a squared plus x squared is equal to 1 squared. A squared is 1 minus x squared. A is the square root of 1 minus x squared. Okay? Now, you can figure out this pattern, guys. If you're missing a leg, it's always going to be the square root of the larger number squared minus the smaller number squared. Larger number squared minus the smaller number squared. Okay? Now I have a triangle with all 3 sides. Can I find the cosine of theta?
wait, would it not just be x? Because you have the square root, so it's not.
No, because it's 1 minus x squared and it's just like together. Okay? And then this is just root 1 minus x squared. Are we okay with this one? Yes.
It's like, let's say like the one with 2 would be 2 squared, right? You just get rid of the one.
Okay, so next one. Tangent of inverse cosine. Right? So let's draw a triangle. Inverse cosine is x. So that means the cosine is x over, inverse cosine of x, the cosine is x over 1. This, right, this side is the square root of the hypotenuse squared minus the leg squared. Okay? You can do the Pythagorean theorem or you can do that. It's up to you. And then what's the tangent here? Correct. Okay? We're good? All right. So, okay. You can't, okay, so suppose you have the square root of 9 minus 4, right? Is that the same as like the square root of 9, 3 minus the square root of 4, 2? Is that equal to 1? Let's see, what is this equal to? It's the square root of 5, which is not 1, right? So you can't distribute a square root like that, okay?